Okay, in this project we are talking about the remainder and factor theorems. Okay, in the remainder theorem. Okay, so the actual remainder theorem is if f of x is divided by x minus c, then f of c is the remainder. The problem is given 9x to the fifth minus 34x to the fourth plus 20x to the third plus 10x squared minus 36. Find f of 3 in two ways. The first way is simply plugging in. Plug in 3 into wherever an x can go, as shown here. Multiply it all out, it looks similar to like this. First end result should be f of 3 is equal to 27. Now, in order for this to work, both the remainders must be 27. Now for the next portion. So our next method is using synthetic division. This is easier than long division and is possible simply because we are using a linear equation. So do it like so. So just break this down here, multiply 9 by 3 and you get 27. Add this to negative 34 and you get negative 7. Then multiply negative 7 by 3 in order to get negative 21. Then add that to positive 20 and you get negative 1. Multiply that by 3 and you get negative 3. Add that to positive 10 and you get positive 7. Multiply positive 7 by 3 and you get 21. Add this to 0 and you get 21. Multiply 21 by 3 and you get 63. Add this to negative 36 and you get 27. As you can see, both have the same remainder. Therefore, f of 3 is equal to 27.
This problem has to do with the factor theorem. The factor theorem is on page 249 of your textbook, and it's section 3.3. Basically, the factor theorem is a result of the remainder theorem and is based on the same reasoning. So basically, the remainder theorem, if you don't already know, is if you divide a polynomial p of x by a factor x minus a of that polynomial, then you will get a remainder of 0. So the factor theorem is the reverse of the remainder theorem. If you use synthetic division for the polynomial by x equals a and get a 0 remainder, then not only is x equal a 0 of the polynomial, but x minus a is also a factor of the polynomial. So we're going to manipulate this problem in two ways. The first way is just by plugging it in, and the second way is using the synthetic division. I'm going to plug in 3 for this equation. Where I got the 3 was from x minus 3 up here, and we're going to prove that it is a factor of this polynomial. So 3 to the 4th minus a times 3 third minus 3 squared plus 128 times 3 minus 240 will equal down to 81 minus 216 minus 19 plus 324 minus 240. And this will result in 0. Now, this is just plugging it in. Now, the second way we're going to do it is by using synthetic division. I'm going to erase this. This eraser isn't working. Oh no. Okay. Alright.
This is in the video, by the way. Wait, why did you say that? Why did you say all that stuff?
Okay. Okay, well that took for a while. Now, synthetic division, we're going to put 3 right here, and we're going to take the coefficients of each number here. So this would be 1, this would be negative 8, negative 1, and so on, including the constant. 28 and negative 240. Okay, 240. Okay. Bring the first one down and get 1. And then 3 times 1 is 3. And then we'll just go on from there. This will be 18. This will be negative 16. Oh no, this would be 15, sorry. Negative 16, negative 48. 80. This would be 240. And this would equal 0. So check. Because it proves that x minus 3 is a factor of this polynomial because we got 0 as a remainder. Okay, so part B, we are going to find the other roots of f of x. Alright, so x minus 3 x Okay, so the roots for this polynomial right here is, I'm just going to read it off. It's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 20, plus or minus 40, and plus or minus 80. And what we do when we have so many roots is you're going to go into calculator and you're going to plug into your calculator, otherwise it will take you forever. And what we found out was that positive 4 works for this as a root, because it equaled 0 in the end. So we're going to put positive 4, and we're going to use synthetic division to make sure that it is a root. And it's going to be 1, negative 5. These are the coefficients of this polynomial right here. So it would be completely factor it. So it's going to be x minus 3, x minus 4, x plus 4, and x plus 5. And the other roots would be 3, would be positive 3, 4, negative 4, and 5. Because we would set each of these equal to 0, and there you would get your answer.